All right there, econ friends. Welcome back to another video. In our last module, we covered supply and demand, and we learned in particular about the law of supply and the law of demand. And we know that the law of supply tells us that there's a relationship between a price change and a change in quantity supplied. And the law of demand tells us there's a relationship between a price change and a change in quantity demanded. In this module, we're going to introduce a new concept called elasticity. Elasticity allows us to take that law of supply and that law of demand and extend them a little bit. Basically, what you have to keep in mind is that the law of supply and the law of demand tell us that there's a connection between price and QD or price and QS. But then the laws stop. Elasticity kicks in by telling us how strong that connection is. You can think of it this way. The law of supply, the law of demand tell us that QD and QS are responsive to price changes, but then the laws stop. Elasticity kicks in to tell us how responsive it is. It's a pretty powerful tool. It's especially important in economic policy and will really be important for those of you who one day want to start your own businesses, because your pricing decisions are going to be really important. And you're going to need to know, if you move your price around, how's that going to affect your customers' behavior and therefore your profitability. So with that little thing said, let's jump into a quick discussion of the theory of elasticity. So in general, by way of definition, we can think of elasticity as a very general, broad term that simply describes the responsiveness between two variables. Note that elasticity as a measure of responsiveness can be applied in lots of different disciplines anytime you're comparing two different variables and how they're connected. In economics, however, what we're really talking about is responsiveness to price change. We learned last time that the law of supply and the law of demand, they describe how people respond to price changes. Elasticity extends that to describe, we'll say, how much or how strongly they respond. In other words, the law of supply and law of demand tell us that there is a connection between these variables. Elasticity tells us, we can say, to what degree. So it's a measure of the strength of the connection, okay? This is really important, especially in the realm of business. Let's take an example. Let's just say that you are a book author. So you write books for a living, and you receive royalties that will equal 10% of your total receipts. Total receipts can also be called total revenues or even total expenditures. It's the same concept, okay? Total revenue or total receipt or total expenditure is equal to how many items you sell multiplied by the price per item. So you can think of TR is equal to P times Q, okay? So you're a book author, you're going to get paid by way of royalties. And those royalties are going to equal 10% of the total revenues or total receipts that are brought in for your books. And again, your total revenues are your total receipts or your total expenditures. Same concept. It's going to be equal to P times Q. P, how much is each item selling for? Q, how many items are you selling? You multiply those, and that's the total spending. Now, let's say that your publisher one day gives you a call, and your publisher tells you that they plan to increase the price of your books from $25 up to $30. The question that comes into play here is, are you happy about this? And the answer, at least for now, has to be, you don't know. Because given this, you don't have enough information. Think about it for a minute. If the price goes up, so we said that the price is going to rise from $25 up to $30. Well, that price increase is going to have two different effects. Number one, the price that is received for the books will obviously go up. But at the same time, the law of demand tells us that as the price goes up, the quantity of books sold will go down. And therefore, if I ask you, are you happy or sad about this? Well, you don't quite know. Because if TR is equal to P times Q, the price increase is going to drive the price up, but it's also going to drive quantity down. And therefore, we don't know the impact on total revenue. We can answer that question, though, and a lot of other related economic questions if we jump into elasticity. Now, there's going to be 4 different measurements of elasticity that we're going to cover. We're going to lead off right now with the big one, which will be the one that we cover the most in class and that you'll be most accountable for in your assessments. And we call that one the price elasticity of demand. Let's first define it. The price elasticity of demand is a measure. And it's a measure of how responsive quantity demanded is to price changes. In other words, the law of demand says that as P goes up, QD goes down, and as P goes down, QD goes up. Price elasticity of demand is going to tell us how responsive that quantity demanded is to those price changes. And by way of computation, it's a simple formula. And that formula is the elasticity of demand is equal to the percentage change in quantity demanded divided by the percentage change in price. That formula is your elasticity of demand formula. Now, in the textbook, there's different ways to crunch it. There's a more simple way and there's a more technical way called the midpoint method. We'll talk about these a little bit more in live lecture. For now, I just want you to focus on the big picture, which is that elasticity of demand measures the change in quantity demanded divided by the change in price. And therefore, it tells us how responsive consumers are in their purchases to changes in price, okay? Let's do an example. Okay, we'll keep our formula handy. That way we can always crunch it out. The percentage change in QD divided by the percentage change in price. Let's do an example. Suppose that the data tells us that the price of oil increases by 10%. So we'll say that the price goes up by 10%. And based on this increase in price, the quantity demanded falls by 5%. So we have a relationship here. Law of demand has kicked in. Price has gone up and QD has gone down. But the price elasticity of demand is asking us by how much. And if we crunch the numbers out, we would say that the elasticity of demand is equal to the percentage change in QD divided by the percentage change in P. That's going to be negative 5% divided by 10%, and that's going to be equal to negative 0.5. Now, one thing I want to share with you, and that would be, by the way, the answer, the elasticity of demand. One thing that I want to share with you by way of shorthand, because the law of demand tells us that P and QD go in opposite directions, the elasticity of demand will always be negative. For shorthand reasons and by convention in economics, we just drop that negative sign. So here what we would say is the elasticity of demand is equal to 0.5, okay? So we just, because it's always going to be negative for this particular measurement, we just drop that negative sign and just give like what we say is the absolute value. So we would say that the price elasticity of demand for oil is 0.5. Let's do another example. Let's say that research shows, the data shows that over a given period of time, Los Angeles housing prices increase by 6%. So prices are going up by 6%. And because of this increase in price, the quantity demanded falls by 14%. The quantity demanded falls by 14%. Well, once again, we would calculate that the elasticity of demand, the percentage change in quantity demanded divided by the percentage change in price, negative 14 divided by 6, negative 2.33, or we would drop that symbol and say that the ED is 2.33. Done. Now notice something really important. Up here for oil, the measurement was less than 0. Sorry, pardon me. It was less than 1, right? It was a fraction, a decimal. This implies that the change in quantity demanded was relatively small compared to the change in price, right? We would say that the numerator, the change in QD, was smaller than the denominator, the change in P, and therefore the whole number was less than 1. We would call this type of good inelastic, and I'll explain this in a bit more detail. Notice that down here with housing prices, while the law of demand still holds, the number, that what we call the coefficient, is way different. In fact, it's greater than 1. And when it's greater than 1, that implies that our numerator, the percentage change in QD, or the buying reaction, is greater than the denominator, than the price change. This would imply that for the number 2.33, consumers are very responsive to price changes. And in fact, they alter their behavior in excess of the percentage change in price. We call this kind of item elastic. So what we're leading to is the fact that once you understand how particular goods operate and how people react to their price changes, we can classify any economics good into one of 3 elasticity categories. Those 3 categories are elastic goods, inelastic goods, and what are known as unit elastic goods. We'll take a quick jump in and define these, and then we'll start thinking of examples and then the criteria of what makes one good something and something else, okay? For an elastic good, the critical thing to understand is that the elasticity coefficient, the ED value, is greater than 1. This means, mathematically, that the percentage change in QD is greater than the percentage change in price. And therefore, we're going to define for our class elastic goods as an item that is very responsive to price changes. Okay? So, because the ED value is greater than 1, that implies that, again, our numerator is greater than our denominator, or said differently, that the percentage change in QD is going to be greater than the percentage change in price. This means that when it comes to what we call elastic goods, consumers are very responsive to price changes. So much responsive that they'll cut their consumption by a greater percentage than the price went up. Or if the price goes down, they'll increase their consumption by a greater percentage. That's an elastic good, okay? So category 1, elastic. An inelastic good is defined as a good where the ED coefficient, that elasticity value, is less than 1. In this case, we would say that the percentage change in quantity demanded is less than the percentage change in price. Okay, let's think about that. For the elasticity coefficient to be less than 1, given how the formula is, for a good to be inelastic implies that the percentage change, in other words, the responsiveness in terms of quantity demanded, is less than the percentage change in price. So we would conclude that inelastic goods are goods for which consumers are not very responsive to price changes. Going back up to our examples here, you see that oil would be classified as inelastic. For a variety of reasons, if the price of oil goes up by a certain percentage, obviously we're not going to be happy as consumers, but we're still going to consume significant amounts of oil. Our buying behavior is not going to be overly influenced by the increase in the price. That's an inelastic good. LA housing prices, on the other hand, we would classify as elastic, and we'll discuss the rationale later, but for now, just know that a change in the price of the homes was offset, was met with the reaction that was very responsive, an even greater change in people cutting back on their home consumption, okay? So we have elastic goods, our second category, inelastic goods. Our third category of goods is unit elastic, also known as unitary elastic. And with the unitary elastic or a unit elastic product, this ED coefficient is equal to 1. And that implies that the percentage change in QD is equal to the percentage change in price, which basically means that consumers are pretty much proportional in how they treat a price change. If price goes up by 5%, they cut their consumption by 5%. If prices fall by 8%, they'll buy 8% more. Whenever the change in quantity demanded pretty much equals the change in price, ED is going to be equal to 1, and we're going to call that unitary elastic. Let's wrap this up really quick with a quick talk about the idea of a continuum. I've told you about 3 unique cases, 3 classifications: elastic, inelastic, and unitary elastic. There's also a couple of extreme cases, and we would call those extreme cases perfectly inelastic and perfectly elastic. And probably the best way to think about this and to view these different classifications is through the lens of a continuum. Whenever you're thinking and analyzing elasticity, I want you to think of it as a continuum. If you take a look here, we start off way over here with an ED of 0. And then as we move out, the ED factor gets bigger, okay? That means that we start off here with a perfectly inelastic good, and we can classify goods along this continuum becoming more and more and more elastic. Let's talk about a couple of things to make sure your jargon's right. On this continuum, I want you to think of it this way. So we're starting here at inelastic, and we're going out, and as we go out, we're getting more elastic. I want you to be fluid with your terminology. So when we say that something is inelastic, it's kind of the same as saying that it's less elastic. We're moving, this way on the continuum. So when you hear that something is more inelastic, that's the same as saying it's less elastic. You're moving in one direction on the continuum. On the other hand, as you move toward the other direction of the continuum, as you get more elastic, that's kind of the same as saying that you're getting less inelastic. Okay, so I want you to be really comfortable with the jargon, with the terminology, and know that if something is more inelastic, it's less elastic, and vice versa. That way, when you hear different terminology in the textbook or in lectures or in the news, you can make sense of how it is. At its core, though, know that it's a measure of responsiveness. And as we go from here, more inelastic, out toward more elastic, we're going from less responsive to more responsive to price changes, okay? So think about it as a continuum. Finally, let's take these two cases, perfectly inelastic, perfectly elastic, and the three that we just learned, regular elastic, regular inelastic, and unitary, and let's identify them on this continuum as different drawings. When you're looking at this, I want you to pay really close attention to the slope of the demand curve. And you will notice that as you move from panel A, which is inelastic, out to panel E, which is elastic, the slopes go from steeper to flatter, okay? Let's take a look. Perfectly inelastic. If you take a look at this, this implies, look at the demand curve is here. If an item is perfectly inelastic, this means that you can change prices to any degree and people are still going to buy the same quantity. You know, if we had here, you know, a price of $10, you go over, people are going to buy 100. If you bump the price up to $1,000, you go over, they're still buying 100. So perfectly inelastic is completely unresponsive to price changes. Of course, if you go along the continuum, you go toward the more elastic side, look at perfectly elastic. We've gone from this demand curve to this demand curve. And look what this tells us. When something is perfectly elastic, it's perfectly responsive. Look at this one. At a price of $10, consumers will buy basically unlimited amounts. They'll buy relatively infinite amounts at the price. But if the price goes up even to 1 penny, to $10.01, they lose all demand. So perfectly inelastic, a completely vertical, upright demand curve, they'll buy the same amount regardless of price. And at the other extreme, perfectly elastic, a horizontal demand curve, if you raise the price by even a penny, you lose all your customers because they're perfectly responsive. And then you can see our other ones in the middle. In case you were curious in terms of items, let me erase this to clean some space for us. If we were to talk about what panels would represent what items, we would probably say that panel A, the perfectly inelastic, it really doesn't exist in the real world. This is sort of like, you know, this mythical demand curve, but we use it as the endpoint and it gives us the mathematics to build our demand. Relatively inelastic, this would be the demand for items like, you know, for example, cigarettes, maybe coffee, medication if you have, you know, an illness, things like that. As we move along to more elastic, this would be the demand for everything from apples and fruit and meat and steak to even, you know, new cars. And as you move all the way along to this far extreme, there's very few cases in the real world of perfectly elastic demand. But one common example, and the one that most textbooks use, would be, for example, the demand, you know, for Farmer Joe's wheat. So if some farmer named Joe has wheat and lots and lots and lots of other farmers have wheat, then Farmer Joe has no real price control. He has to charge the market price, because if he charges any more than that, you'll say to hell with his wheat and go buy wheat from all those other farmers, okay? So that's our continuum. Note that the jargon, and note also the slope of the supply, of the demand curve. And this leads us to our final thing that I'll talk about in this lecture, and then we'll cut it. As a general rule, if you have two demand curves that you're comparing, and if they have a point in common, the steeper demand curve, the more upright, steeper curve will be more inelastic, and the flatter curve will be more elastic. So if we look at this simple drawing, you see that D1, very flat relative to D2, which is pretty steep, you would say that D1 is more elastic and D2, the steeper one, more inelastic. With that said, that's a great start, a great intro. In our next video, we'll go into the numbers a little bit more and we'll learn some applications of price elasticity of demand. Thanks for tuning in, and I'll talk to you soon. Bye.